It sounds like the beginning of a modern myth to take a flying motorcycle 15,000 feet in the air, especially given that it's capable of 300 miles per hour speeds. Welcome to the new video of incredible tech. Let's dive in. For the past 10 years, Jetpack Aviation has been at the forefront of the mini personal VTOL market. They're focused on creating the safest, smallest, and fastest VTOL aircraft and are based in Los Angeles, California. They developed and produced the first portable jetpack in the world between 2010 and 2015. After putting in years of effort, David Mayman launched Jetpack Aviation Corporation in 2016. David started off as a management consultant and then built a number of prosperous tech firms. He's a skilled pilot who has commercial certificates with instrument ratings in America, Australia, and Europe for both fixed-wing and helicopter flying. When CEO David Mayman completed the first ever FAA-approved jetpack flight around the Statue of Liberty on November 3, 2015, Jetpack Aviation created aviation history. Additional public flights in Los Angeles, London, and Monaco proved beyond a shadow of a doubt that our man-machine feat has pleased individuals from various backgrounds, interests, and experiences. California's Jetpack Aviation has finished flight testing on its first prototype of the Speeder, a jet turbine-powered flying motorcycle, after spending 18 months developing an entirely new sort of flight control software. The final version's top speeds will be quite impressive. The Speeder from Jetpack Aviation is a sci-fi fantasy brought to life. It resembles a combination between a Star Wars speeder and a jet ski or helicopter. The 231-pound device, which has 4 turbojet engines, can run on diesel or kerosene. Additionally, it has a fly-by-wire and is completely stabilized. And now it's prepared to go on sale. The company's jet-powered device, according to Luxury Launches, finished a successful set of tethered test flights over 5 months earlier this year. The P1 prototype had the capacity to lift off, ascend into the air, hover there, turn and spin, and conduct gentle transitions to forward flight. The business has already started developing a more sophisticated prototype. It'll swap out the previous model's substantial aluminum chassis for a more compact one made of body panels made of carbon fiber. Additionally, the third prototype will already have a fully formed body and small wings, thanks to designs by Jetpack Aviation. Moreover, there will be twice as many engines, which according to them will enable objects weighing up to 600 pounds to fly 300 miles at the height of 50,000 feet for 20 minutes. All of this is possible with a VTOL, or vertical takeoff and landing machine. Additionally, leisure and military commercial models of the world's first flying motorcycle will be available, each with a hefty $380,000 starting price, which oddly enough is the best reason to like this machine, which is both fascinating and horrifying. Icarus wouldn't have needed to use wax if Daedalus had invested so much in his wings. The most important aspect is that, like an electric VTOL, it would likewise be electronically self-stabilized. This may seem regular and straightforward, but electric motors generate torque almost rapidly, which is how swiftly multi-copter drones and electric VTOLs can change thrusts between several propellers and balance themselves in the air. In fact, JPA has ground up IP for a self-balancing VTOL system that may be used with a variety of propulsion sources other than electric ones. Anything can be thrust vectored, regardless of size or configuration. The US military's Agility Prime project will take note of the fact that the product was also made in America. Additionally, it goes beyond the VTOL system. Each jet engine is likewise gimbaled, although according to Mayman, those are difficult to move quickly enough for flight stability due to the gyroscopic forces present in quickly spinning turbines. This enables the jets to rotate backwards for fast forward flight, fully backward for the rear jets, and 60 degrees backward for the front jets. Mayman explains that's just an airframe issue. In our current design, you'd effectively set your airframe on fire if you tilted the front jets totally backward. This allows the speeder to fly horizontally at high speeds and distances when detachable wings are clipped onto the sides. For many use scenarios, it'll be sensible to transition into horizontal flight as soon as feasible because, like all VTOLs, it'll consume a lot of energy in a hover. According to Mayman, the speeder will be modular, stackable, and capable of being launched from a launch pad, the back of a vehicle, or a trailer. Wing alternatives, which come in various sizes from various mission profiles, might be placed conveniently next to the body. It must be modular and adaptable to the field because there'll be occasions when you only want to fly the chassis. It is conceivable to employ a wet wing with a bladder full of extra fuel in it for extremely long-range work. The top speed of this flying motorcycle is largely governed by its shape when wings are fitted. Mayman explains, "You're talking about motors here that typically fly at Mach 0.8, 600 plus miles per hour, so we can expect to go at speeds of more than 300 miles per hour with a wonderful slippery cargo version. Potentially substantially more than is insane, because the pilot must be able to see. Manned versions will often go slower and have open tops. Winged flight would probably require some form of control surface, all of which would be programmed into the flight control system to maintain the pilot's fly-by-wire control system. This presents the flight engineering team with a brand new set of challenges because the software will need to be equally flexible to various aerodynamic shapes as it's to various thrust and weight configurations. As for the final aircraft's appearance, that's still kind of up in the air. The single densely packed 5-jet propulsion pod that's seen in the original drawings under the center of the bike will not be used by the speeder. According to Mayman, that was useful for redundancy but useless for directing thrust into a winged flight mode. Running 2 turbines in each corner will assure redundancy. JPA will presumably adopt a head-first, belly-down riding position similar to that of a motorbike, or it may adopt a recumbent seat that would create something more like a flying go-kart. Or both. Jetpack Aviation doesn't care how this thing turns out at this point in terms of appearance. Instead of just creating one product, the company is developing a platform that can be configured to run a variety of different airframes with a variety of different propulsion systems, depending on the needs of various customers. It could transport 660 pounds of fire retardant over a fire before it has an opportunity to really rage and could deploy without a pilot from a base on the back of a truck very quickly. For such kind of work, a large electric VTOL is required. According to Mayman, lightning detection technology has advanced to the point where it can now predict the beginning of a fire. We're raising our hands because it's now taking them too long to get an asset onto the fire. There is a possibility to focus on terrifying noise that these jet engines produce. A possible solution, according to Mayman, would be to scallop the exhaust tips like they do on commercial jet aircraft. This would lessen and potentially even partially phase out some of the sheer noise produced when a jet's exhaust moves quickly and collides with still air. Another option would be to place acoustic aerogel sound absorption around the turbines themselves. The P2 is a wholly distinct machine. It'll once more be smaller. The tether hold from above is gone, and we have some extra hand grips. The hardware and software for the flight control system are essentially identical. Since the jet evaders are a new design, testing is necessary. The gimbal mounts that allow the engines to tilt backwards and forwards have undergone a thorough redesign. The entire frame has also been redone, just for aesthetic reason. P2 won't resemble a test bed at all. It'll appear more like a flying motorcycle. It'll resemble the airplane in production quite a bit. If you liked the video, don't forget to hit the like button and subscribe to our channel.